Hello, good morning, everyone. It's 10 a.m. I went to sleep after Thunder because normally I would read a little bit for like an hour or so. But I remember the last time I did that, I was like scared because I spent so much time in the morning reading that I was like, if I sleep now, I'm gonna miss all the time for my final. But then I stayed up, my head was hurting excruciatingly, so I was like, I don't want to go through that again, so we're gonna start like studying, then maybe catch up on reading afterwards, after this final. But so far, when I take a look at the final review, everything before I started studying like a few days ago, it didn't make nothing made sense. But now it's starting to make sense because you know. So let's see. This makes sense. ANOVA versus summary on LM commands. So ANOVA does stepwise testing, and summary. So this is ANOVA doing stepwise. I think the last thing is this thing that I haven't studied yet, but I remember doing it for the second midterm, so I have to just write down like the formulas and all that. But I'm not really sure where I left off on my cheat sheet, so let's see. Comparing best subset selection to forward, backward, stepwise. I feel like I wrote that somewhere, but a little hard to read from here. So over here we have stepwise selection, start with intercept, faster, and gives good model. So computationally faster, okay, gives a good model, right? But also requires the p size to be large. Or works well when maximum model size p is large. When p is large, best subset selection becomes too slow. So stepwise selection is good for this. Okay, so let's put that here. Actually, this is too packed. I'll just put p over 25. It requires that for stepwise. Over here we have ANOVA, right? Or best subset. This makes absolutely no sense what I wrote down here. Advantages of best subset: simple method, intuitive, identifies the best model. Disadvantages: computation cost is too high, 2p model needs to be considered, p can't be above 20. Okay, I wrote that. Best when p is small. What? I had 13 viewers and then they all just left. Anyways, we're doing this for ourselves. Okay. Hello, Zay. Welcome to the stream. Let me know if you have any finals that you have to study for as well. Like, how are you doing? This is a really hard week for many students, such as myself. But we do need a brief support. So the optimal value of lambda selects 10 since it gives the smallest cross-validation error. But that's for lambda. This is, I don't know what this is saying. The proportion of variability in y explained by the model is 43.2% because this is the r squared value. Where would you see that? R squared. Where's the r squared value? Hello, Rios. Welcome to the stream. I'm good. A little bit stressed. Not too much because I feel better than I did a few days ago when I knew absolutely nothing and I didn't study. But now I did study and I understand the material, but I'm still a little bit stressed because you never know what the exam's gonna throw at you, you know, something that you have not prepared for. And I'm trying to prepare for everything, but that's the overwhelming part. I'm trying to find where r squared is. Because where did he get 43.2% for this brief support? Oh, well, it's just probably just an example, right? So I'll say on this paper down here, another example of brief support is, or to write the brief support. What grade am I in? That's a good question because I'm not actually in middle or high school. I'm not even in college. This is not even, you know, this is university level. So that's the highest grade. That's like 1 billionth grade. So, and I'm not, yeah, I'm not as old as you probably think though. But I'm not gonna say how old I am. I'm just saying. Anyways, I need to know how to answer that question better because I've been asked that before and I always like get a little bit shy. My sister gave me these. Look at these stickers. Aw, so cute. Pomegranates. Wow. I need something to use these stickers for. In 9th grade. Wow. That's a big grade. Is it hard? So another example to write brief support is the proportion of variability in y explained by the model I mean kinda. Really? So what topics do you guys study? Oh man, this pen's been on the whole time. I struggle in ELA and math. English? What is ELA? I was trying to think of ESL, but that's not English second language. ELA, let me guess. Language arts. English language arts. Yeah, math is hard. You need a lot. Yeah. See, I was right. Explained by. So what part of language arts is so hard? Is it the reading? Because I hate reading. I failed an exam because of the reading section. And I will say this to everybody, whoever says like, oh, do you like reading or something? But yeah, it's so hard. It's like, I ain't reading all that. But, you know, reading is good for you, apparently. This is the R squared by. What about math? What level of math is the hardest? Are you doing trigonometry, geometry, abstract, or not abstract, but just algebra? K distance, use for K and then regression. Do you have to read whole books? Like, oh, my cat. Do you have to read like Shakespeare, Romeo, Juliet, Hatchet, Lord of the Rings, stuff like that? I've never read any of those books entirely. I always went to these old websites that had summaries, and I just base all my essays on those. Let vector A, vector B in the reals. Actually, that's not the real. It's like reals to the P. L squared or L2 distance is the Euclidean distance, which follows the formula of square root of the sum of. Did he leave the stream? AI minus BI squared. Then L1 is the distance, Manhattan distance. I love, how this professor teaches. Oh, you're still here. I do algebra, geometry, and... Oh, dang, that's a lot. It's very hard. I equals 1. I forgot the other thing. Probably trigonometry. I don't know, that's just my guess. But the thing about math is that you don't have to read too much. You just have to practice the problems. Like, I love computing stuff. It's so, like, I hate when you have like a minor error, like a negative sign, and then you get the whole answer wrong. But at least you get partial credit for that. But reading, like, you have to go through the entire thing. I'm like, I ain't reading all that. The worst part is when math like has these reading portions where you have to read it. And oh my gosh, when you get to math proofs, you're gonna have to write a whole essay based on those things. It's crazy, man. If you end up taking math proofs. Hopefully you don't have to, though. It's torture. But my major is applied mathematics, so I have to. 2 minus 0 squared plus 1 minus 0 squared equals square root of 5. And then dl1 is... So I think I'm prepared for my review, for my final now. But I'm still a little bit anxious because I have a lot of paper left on my paper. A lot of space left on my paper. So I could write anything. Let's practice some concepts. Oh, No, I don't think I went over ridge. But yeah, I do trigonometry. That's that's really hard. It's like you have to memorize a lot for that. Not just trig, but like calculus and stuff. Like you have to memorize like 30, 60, 90 triangle, um, hypotenuse. Man, I can't even. Oh, secant, tangent. Man, that part is so confusing. Like, yeah. But the more you like practice it, I think the more you'll remember. But that's the hard part because you have to be really repetitive for it to be in your head. Even if they give you some formulas and stuff, it's better to just memorize it. After acquiring the best model for each k, why cannot we use the regular r squared to choose the optimal model? Because r squared guaranteed to be larger or equal to the larger models. So r command for best subset selection. I think I went over these yesterday. Okay. This is a lot of stuff. So, do you still have exams? Are you still in school, or do you have a break right now? Because a lot of people have break already. So, ridge regression is L2 penalty. Ridge minimizes sum of y minus yi hat squared plus lambda summation beta squared j. What ridge does, shrinks coefficients towards 0, makes big coefficient smaller, helps with multicollinearity, and what ridge does not do is it never sets coefficient exactly to 0. So it keeps all predictors. Okay. Towards 0. That's important because I thought it was absolutely 0. Towards. Okay, so what ridge coefficient plot means? On the plot, x-axis is log lambda, y-axis is the coefficient values. As lambda increases, the lines slowly move towards 0 but never touch 0. With an asymptote. So interpretation, all predictors stay in the model but with smaller influence. And the L1 penalty, the lasso minimizes the coefficients. So it forces some coefficients exactly to 0. That means it does automatic variable selection. Okay, so lasso takes it to absolute 0. Let's write that down. Lasso takes coefficients exactly to 0, while ridge regression takes it towards 0, but in all predictors stay in the model, but keeps all predictors. Okay. Ultra important comparison. Memorize this. So the penalty L squared is ridge, L1 is lasso. Okay, shrinks coefficients, yes. Set some beta equals 0, no, yes. Variable selection. I don't know what variable selection is. Welcome to the stream, Maria K. Nutus. Main name is Waldemar. Oh, welcome to the stream, Waldemar. Maria. You have 4 tomorrow. What exams? Dang, Reels, did you study for them? That's crazy. 4 is insane. I have 1 exam today. It's at 5 p.m. I have to leave by 4:30. Doesn't make me anxious though. You studied. Nice. How many hours did you study? Because apparently to succeed in an exam it takes at least 10 hours. And I aimed for 8 hours total. It's ambitious of me to aim for 8 hours per day, but I cannot be bothered to do that. As anxious as I was still watching Stranger Things. So which method removes variables from the model? Obviously B. Yes, B is correct. Next concept, lasso cross-validation plot. Choosing lambda. This is a slide right after the original lasso plot. It's 100% showing up on your exam. I'll explain it super simply. Exam level. What the plot shows, the y-axis, blah blah blah. How to choose for an exam. Which lambda should you choose? Why? Choose lambda min. Simplest model. Choose lambda 1 SE. Okay. Which model has the better predictive performance? Which model is simpler? Which lambda would you choose if interpretability is the priority? 4 days of study. 1 math, 1 social. Studies, 2 ELA. 2 ELA! Oh my god. That's like your worst subject. Or not your worst, but like your least liked. But do you like social studies? I feel like social studies is pretty interesting. But I could care less about what happens to other politics and countries and stuff. So you like social studies? Lowest CV error for lambda min, lambda 1 SE, is the simplest model. Lambda min left vertical line. I love social studies. It's my favorite class. Nice, nice. It's good to have a favorite subject. I think out of all my favorite, out of all my subjects, I think math was my favorite just because I was good at it. But there's a difference between being good at something and actually enjoying something, because I feel like that's the main difference when I do math. Like, I could be good at it, but always it gets confusing. It's really abstract sometimes. So what do you like about social studies? Lowest cross-validation here. That's my cat. She's like, yeah, I have 2 cats. Yeah, I'm matching with them too. more complex. Gives the best predictive performance. Right vertical line. This is the right vertical line. It's the coefficients. Error is slightly higher but simpler, fewer not zero coefficients, more stable model, often preferred in practice. I feel like that won't be on the exam, but that's what ChatGPT is saying. I have a dog, Shih Tzu, so cute. What is Shih Tzu or Shih Tzu? The one thing I like about social studies is like less work, funny, and sometimes we get like free time. Oh wow, I thought you meant you like the subject in general, but it's probably just the class. Sometimes, honestly, like it's not about the subject, but the person teaching it that's like makes it more enjoyable. Like, I don't hate studying, but the part that I hate about studying is sometimes you don't know what to study. As much as you try, it's like it's not good enough because you don't know exactly. Oh, Shih Tzu. Aw, it's so cute, bro. Reminds me of that Barbie. This one. What was it? This one. Actually, it's not Shih Tzu, but it's so cute. Aw. Man. What do you find funny about social studies? Because when I had social studies or like history class in general, it was so boring I used to fall asleep doing films. And then I'd wake up last minute and write a whole page of notes based on nothing. And I get 50% on it, but I would be like, oh, thank God, because I'd have gotten a 0 instead. So my professor, or my teacher at that time, he was like, whoa, you're crazy, because like, you know, I was happy about 50%. It was still an F, but you know, it's better than 0. But simpler, fewer non-zero coefficients. Man, I need some new pens, bro. My dog's name is Emily. Aww. Her name is Pixie. That one's name is Yuki. Oh, what is she doing? Okay. More stable model. None of my pens are working, bro. That's crazy. She thinks it's a toy. The funny thing's my teacher and the subjects. Oh yeah. That's how you make a class more entertaining. That's why it's your favorite. I feel like if I were a teacher, I'd do a better job at teaching than a lot of my teachers. But sometimes it's better to play it safe than to be someone's like worst teacher. I would never want to be someone's worst teacher, you know? That's so sad. Okay, so here's a mini fake exam question. Super quick. The lasso CV plot shows lambda min at negative log of lambda equaling 2 within 10 with 10 non-zero coefficients. 4 non-zero coefficients. Which model has a better predictive performance? So this would be e to the 2, right? And then e to the 2? Or would it be e to the 10? And this one would be... Honestly, I don't know. Better predictive performance? Wait, we wrote that. Let's do lambda min. And then B would be which model is simpler? Lambda SE, right? LISE, and then C would be which lambda would you choose if interpretability is the priority? Oh, they didn't say that part. I mean, if lambda SE is more preferred, I'd say that. Okay, you gotta go. Nice. Thank you for staying, and see you in future streams, hopefully. Have a good rest of your day. Okay, so I got 100% correct. Get best subset selection and how to read the charts. This corresponds to the slides. Best one component model, best two component model, determining the overall best model based on the BICs. You can have a guaranteed final topic, which is what best subsets the selection does. It fits every possible combination of predictors of size k. It picks the best model for that size based on r squared, adjusted r squared. I thought AIC and CP were the same thing. Anyways. Blah, blah, blah. Fake exam question, try this. BIC's highest at k equals 1 drops sharply to its lowest point at k equals 4, then starts rising again. What is the best model size? Say k equals 4. And then B, how do you explain the choices in boost support? Or say it's k equals 4 since the optimal value of lambda flex 10 since it gives the optimal value of k equals optimal value of k equals 4 because it has the lowest BIC. But why is low BIC best? Because less errors? I forgot. Perfect again. You got the model selection logic down cold. Okay, and then lowest BIC. Next concept, comparing best subset versus forward, backwards, stepwise selection. I don't know if I'm ready for this part though. But this is easy points on the final to understand the differences. Okay. Blah, blah, blah. Right. A, best subset selection. Which method is most appropriate? Oh, I have to choose A, B, or C. So p-value, if it's greater than 20, you can't use the best subset. You'd have to use like stepwise selection, but I don't know the difference between forward or backward. But I would say B then, just because we didn't really cover backward selection. Okay, so that's correct. Backward stepwise can also work, but it requires fitting a full model first, which may be problematic if P is just large relative to N. So forward is a safer, more correct choice. Okay. I guess maybe that's important to write, because backward, stepwise requires fitting a full model first. Which may be problematic if P is large relative to N. Which is problematic if P is relatively larger than N. So forwards is a safer, more correct choice. Alright, next subject, next concept, brief support. For adjusted R squared for models as 2, 3, and 4, it is this. So you need to choose the best model using adjusted R squared. That has to be k equals 3. 3 highest, because I just saw it was highest at k equals 3. We choose oh, so you write the value. Okay, I put just 3, but yes, you should put the value. Okay, got it. Next concept, L1 versus L2 distances. Actually, should I write this down? I'll just write it down in case. Brief support example. We choose k equals 3. Because it has the highest adjusted R squared. At 0.68. Oh, Pixie! She brought her toy. You're so cute, bro. Alright, we're gonna have to take a break, I guess. This little girl wants to play. Her pop's in the bag. He woke up. Actually, I didn't mean it when I said we're gonna take a break. All my viewers left. We're at 0.68. Maybe that's a sign I should play with her. Oh, she's so cute. Alright. Almost done. We just have to go over this last concept, K&N regression. So the L1 distance is this. Okay. So, quick practice between points 3 and 8 and 10 and 2. Oh my gosh, she's so cute. I think this one you have to take the absolute value of what? Let me look at the of x1 minus x2. So 3 minus 10, that'd be negative 7 minus or plus absolute value. So that's like 7 plus 8 minus 2, which is 6. 7 plus 6, 13. So would that be L1 or L2? L1. 13. And then B would be the square root of 3 minus 10, which is 7. 7 squared is 49, plus 6 squared is 36. 49 plus 36 is 85. And then 85 root 85. I'll just put that again. Perfect again. Okay. Got it. You have now covered every major topic in your final review slides. Want to do a full mini mock exam? Let's do it. Yes. Okay. Question 1, ANOVA versus summary. So summary shows that X3 has p-value of 0.40. ANOVA comparing models with and without XP shows p equals, dang, that's small. Which result tells you whether X3 improves the smaller model. Oh, if we look here, well, I'm not sure now. That's a hard question. She's so cute. I don't know where that even came from, but oh shoot. Hello, Nina Mess. Oh no. Sorry, this tripod is ruining my phone. It's not normally this chaotic, by the way. Just to put that out there. I'm usually studying without distractions, but you know, gotta give my cat some time. But anyways, let's get back to this. So, which result tells you whether X3 improved the smaller model? So, if it improves the smaller model, I'd say summary then, right? Because it has a higher p-value. Let's say A for question 1. Well, I'm not sure. Let's say, but I'm not sure because smaller p-value means insignificant. Okay, number 2, question number 2, what was that? Nested model selection. Your significance level is alpha equals 0.01. At one step, adding a new variable gives p-value of 0.017. Do you keep the bigger model or stop and stay with the smaller model? Well, it is bigger than alpha. I think you should stop then. Let's see. If the p-value is less than or equal to alpha, reject HO. So HO would be model contains. So accept HO. So it has to be less than. Honestly, this part is confusing. So you have a lot of steps here, right? So all these p-values are less than alpha, so you always reject the HO. And the HO here is that it contains only these. The H1 contains more predictors. So you can't reject it, the HO, if it is bigger. So you don't reject the HO. That means you accept the HO. You don't reject the HO. What is... Man. So you stop instead of small bubbles. Yes. And number 3, global F test, the ANOVA table for a regression model is the degrees of freedom is 4 and 55. Incidence is 120 and 80. And then you compute the F-stat. You don't need a p-value. What? How do you compute the F-stat? Dang. I don't remember going over this. I don't know. Honestly, I don't know. But if I could guess... No, I can't even guess, bro. But the ridge versus lasso, which method can produce exactly 0 coefficients? Lasso. B. Number 5. Cross-validation plots. Lambda min gives 12 non-zero coefficients. 5. Which value gives a simpler model? B. And then 6 would be brief support. Adjusted R-squared value. Which model size is best? Write a brief support sentence. K equals 3 is the best. Model size, since adjusted R-squared is 0.63, which is highest. And then number 7, best subset versus stepwise. We have P equals 32 predictors. Has to be forward. It could be both B and C. I'd say D then. But preferably D. So question 8, lasso log of lambda conversion. You see this in the CV plot, compute your answer can be e to the something, no need for a calculator. I say e to the 3. Actually, no. If you're taking negative log, that's to be e to the negative 3. That's confusing. So number 9, canine distance, the L2. Well, this one's the square root one, so 4 minus 9 is 5, absolute value, plus 10 minus 2, 8 squared. 5 squared is 25, plus 8 squared, 64. 25 plus 64, 25 plus 64 is 9. 89, root 89. I probably did that wrong. I'm not good at mental math. So a model has R-squared equals 0.72. Give the exact correct interpretation. What? Interpretation? I don't know. How do you interpret that? That's at most an 8 out of 10. Correct answer is B. Why is he saying amazing job though? The answer is summary. Summary tells you x3 is significant, controlling for x1 and x2, the full model. Oh, for question 3. So you have to calculate that? Oh god, that's crazy. The MSR. And then how did I get most of these right? Like these are all. Oh wait, a 9 out of 10. He's just being nice though. Look at this. Why did he show the X here? Okay. Question 8, your correct answer is this. Oh, that's correct as well. Okay. Oh, best subset would be too slow. Okay. So I guess the only thing is the global f-stat. What about question 10? Interpretation of r squared equals 0.72. So 72% variability in y is explained by the model. Oh, okay. So it's basically another brief support. This is interpretation. Got it. Well, I'll have to see about the f-stat thing. So compute MSR, compute MSE, and then you divide both of them to get the f-stat. That's crazy though. Anyways, I think I'm done studying for now. Yeah. Bye guys.